Hi everyone, welcome back. So this is Ms. Dingman with our next video. This video is going to be about graphing basics. We will discuss the different types of graphs you can make and when you should choose each type. We'll talk about how to make and create that graph right inside of Excel and ensure that it includes all of the information that's needed for a good graph. And then we'll also talk about how to analyze a graph and answer questions related to the data found inside of a finished graph. So to begin, let's review the different types of graphs we could make. So this is a quick look at the different types of graphs that are out there. We'll mostly focus on three of the main categories. The first category is a bar graph. You can see this is a bar graph that runs horizontally and a bar graph that runs vertically. There's really no difference between them. It's whichever one you like and whichever one best represents the specific data you're working with. Bar graphs are used to show data that is not connected or not continuous. So this would be different amounts or frequencies or categories, and the idea behind a bar graph is that you want to compare the data to one another. Bar graphs help us to make generalizations and see differences between those different categories. The next type of graph is a circle graph, also known as a pie graph. These are used to show parts of a whole, and we should only be using pie or circle graphs when we have percentages that add up to 100. If we have percentages that add up to more than 100 or less than 100, then a circle or a pie graph is not the best choice to make. The last type of graph we'll use in class is a line graph. These types of graphs are used to show continuous data or data that is connected. Line graphs have data that are connected by time, so seconds, minutes, hours, years, decades, some sort of trend over time. And so we can see how that data changes over time because the line will either trend up and increase or decrease, or there will be spikes or plateaus, and that is what a line graph enables us to analyze. So now we're going to go into our Excel document and look at how to actually create a graph. So the first part of creating a graph is to actually input all of your data. So you need to have all of the numbers that you want represented in a graph typed in to Excel, and definitely put titles on top of each of your rows or columns, and that will help Excel to figure out what type of graph is best. The very first step of making a graph, once you have your data in, is to highlight all of your data. So you would click on one of your cells and fully highlight or select it so it's all slightly grayed out. If you don't do that and then you go to insert a graph, it will just insert a big white box. So let me show you what that looks like. So if you don't highlight and you just click somewhere and you do insert, like let's say a line graph, and you click, you'll just get this big white box with none of your information in it. If this ever happens to you, just delete it and ensure that you have highlighted all of the numbers that you want represented in the graph. Then we'll come up to insert, and if you already know what type of graph this needs, which if we look, we have a time and a distance happening over time, so we're going to need that line graph. But if you're not sure, you can ask Excel to see what it recommends. So you can see the first graph that it shows you is a bar graph. Now we know that these distances are connected over this time. It's not separate distances. So a bar graph doesn't really work here. So I'm going to need to use my decision-making skills and my knowledge of types of graphs to go down and choose this line graph, either a line graph with the points, which is called a scatter, or a line graph without the points. Either or is fine. I tend to like the points. Once I know which type I want, I'll click OK, and it will insert it. After I've inserted it, I'm not yet finished. I have to really look and make sure that it has all the parts of a good graph. One way to remember all the parts of a good graph is by using the acronym TAILS. So TAILS has its first section as T, and that stands for title. So we're going to want to ensure that our graph has a good title. Now, Excel will give you a title based on your data, but it's usually not the best. The best title really includes all of the information I'm about to see and enough detail that if you were to tell someone just the title of the graph, they would be able to do a pretty good job of predicting what they're about to see. So our title should always match exactly what's shown. So if we look at our title right now, it just says distance. Distance isn't the only thing I'm showing here. I'm also showing time. So I'd want to include some sort of mention of time. So to change my title, I'm just going to double click right on the title till I see my cursor, and then I can change my title to whatever I want. So perhaps we knew that this information came from a car. So maybe it's a car's travel over 3 hours. So this title is detailed enough for my audience member to be able to guess what they were about to see. So that's T of tails. The next part of tails is A. A stands for axis. So we want to correctly label our X and Y axis with a label and a unit. So to do that, we're going to come back to our chart. To get our axis label to show up down here and on the side, we're going to go to my plus sign, click Axis Titles. I could use my little caret to click that I want the horizontal axis and the primary axis. Once I see that they've showed up, I'm going to double click on them, same way I did with my title, and start typing in what they are. So this down here is our time. I'm going to label it with my unit of hours, and this title over here is my distance, and I'm going to label that with my kilometers. The next part of tails is I, using consistent intervals. So making sure that my X and Y axis intervals are spaced evenly. They don't have to be the same. As you can see in this example, the time axis goes up by 0.2, while the growth axis goes up by 0.5. Whatever makes sense for the data that you're looking at. So the intervals don't have to be the same on the X and Y axis, but they should be spaced evenly and used to best represent the data. So this right here looks good. It's gonna, for the most part, Excel will guess what axis makes sense for the data that you're working with, but you can always increase the size and click on the axis themselves to make some changes if you wanted to. You could click in them and then work on your axis options and look at exactly what values are used in each of the axes if you wanted to change the interval. The next part of tails is L, which is label a key, and that's only if you need a key. In this case, I only have a single line, so I don't need a legend or a key. If I did have multiple lines or different color bars or different slices of a pie graph, I could click on my plus sign, come right down here to legend, and add that legend in. You can see for this example, it's just going to give me that my blue line is distance, which I already know that, so I don't really need to add that in and take up space with a legend. The last part of tails is S for size, making sure that we always have a big graph that uses up a really large portion of our graph paper or of our Excel sheet. So in this case, this is a good size graph, but I think it could be a little bit better. We really want to make it easy to read for any audience member and easy to navigate. So that's all the 5 parts of tails: title, axis, interval, labels or legend, and S for size. After you've finished working through tails, you could choose to design it and change up how it looks or what color it is, and that's all up to your own personal style. You could change the colors if you wanted to and just make it look whatever best represents your data. So we're going to do another example really quick, and this is our data right here, so we can see elements and percentage found in dry air. These numbers do add up to 100%, so I could use a pie graph. So again, I'm going to click, highlight my data, insert, recommended charts, find a pie graph since I know that that's the best, hit OK, and work through tails. So title, percentage of elements that are found in dry air. Axis doesn't really apply here since I don't have an X and Y axis. Interval does not either since, again, I don't have an X and Y axis. L does. I have a legend, and all pie graphs automatically come with legends. I can change where it goes, though, if I wanted it perhaps to be on the left-hand side instead. The other thing that's good to add with a pie graph is data labels, so it actually puts the numbers from your chart right into your graph, so it makes it easier for your audience member to see. And then size, we could make this a little bit larger. And then of course we can play with the colors and the design and change up how we want to view our finished product. We'd want to make sure that we choose a design that makes the most sense, is easy to read, and allows the viewer to fully understand what they're looking at. So sometimes you need to go through and make some different choices, and sometimes even maybe go back to your original choice. Okay, so that's how we create different graphs in Excel. Now, once we've created graphs, we'll be asked to analyze them. So there's two major ways that you can analyze a graph. The first one is interpolating. Interpolating is looking for data that was not collected originally, but can be collected and predicted using the current data line. So if you look here, this graph, our question is, what was the number of cases of X disease in some land during 1977? So I would come over to where 1977 would be on my graph, go straight up until I hit the line, and then over to my y-axis and make a prediction of about 500. The next type of way to analyze is called extrapolate, which is similar to interpolate. So extrapolating is predicting data that was not collected, but can be found by extending the line in the current direction or trend. So you can see here our question is, what would be the tree's height when it was 27 years old? 27 years old was not originally on my line, so I had to extend my line using the same trend or the same slope to make a prediction. Once I've extended that line, I can come over to 27, come up until it hits my new extended line, over to my y-axis, and about 75 would make sense for the tree's height at 27 years old. So that concludes our video for today. Please make sure that you do your understanding check using this Google form. You can use the QR code or the URL, and you'll come in here and answer 5 quick questions about what you saw in this video, and it is worth 10 points. You need to complete this before tomorrow's class, and when you come into class tomorrow, we'll be able to go through some questions and then start some exercises where we evaluate some different data sets and decide which chart or graph will be the best to represent them, and then actually practice creating those graphs and using tails to ensure accuracy in Excel. Have a great night, guys. See you tomorrow.